Actually, how many number of zeros? Am I reliable on those number of zeros? The given number certainly is less than 1 speed of light in vacuum. So either I have measured in CGS system or I have measured in MKS system. Non-zero. What do you mean by non-zero? Hello students, this is SDsir again, helping you all to commit errors, rectify errors, and in today's session, a new type of commitment where SDsir will teach you how to analyze the final result once the errors get rectified. So a very beautiful topic of discussion in today's class, what we call as significant digits. The whole course of today's class is make you all understand what is a significant digit. Very clearly, let me explain to you all the rules involved in identifying significant digits, and finally the arithmetic operations involved in significant digits. So without getting late, let us jump into the pit of understanding what actually is a significant digit. Now, before I go to the proper definition of significant digits, we will first learn the rules, a set of rules that will help me to identify significant digits. And once I understand the set of rules, only then I will make an understanding to the definition of a significant digit. In significance andre something important. He is a significant member of the Indian cricket team, very important member, a person who carries a lots of weightage. So the word significant explicitly means something which is very important, something which carries lots of weightage. Then what are significant numbers? What are these digits with maximum weightage? How do I analyze them? That is what we understand through the set of rules. Rule 1. The rule 1 says all non-zero digits, very clearly, non-zero digits are always significant. Any non-zero digit is always significant. Non-zero. What do you mean by non-zero? Non-zero andreno? A digit which has a defined value. A digit which has a defined value in the number system. Something which is other than zero are always treated to be significant. For example, if you consider the number 2, is 2 a significant digit? Yes. Why is it significant? It is non-zero. It has a defined value in the number system. It is non-zero, therefore it is significant. Hence, the number of significant digits in 2, there is 1. So, the number 2 is considered to be significant. Yes, it has a weighted value. Now I consider the number 24. So, I am considering the number 24. How many digits are present? 2. Which are there? The first digit is 2. The next digit is 4. Are they significant digits? Yes. Why? They are non-zero. Both of them have a specific value in the number system. They are non-zero digits. Therefore, I say the number 24 carries 2 significant digits, 2 and 4. If I come to the next example, for example, 347. The number 347. What are the digits present in it? 3, 4, 7. Are they significant? Yes. Why are they significant? Because they are non-zero digits. They have their own specified values. Therefore, I say there are 3 significant digits present in this number. So, very clearly, the first rule says all non-zero digits are always treated to be significant. Any digit other than 0, any digit which has a defined value in the number system is a significant digit. So, my dear friends, please do keep in mind, the first rule says that you are treating all non-zero digits to be significant. Here comes a practical numbering. Suppose I promise you a salary of 10,000 rupees. My dear friend, I am happy with your work. I have promised you a salary of 10,000 rupees. But at the end of the day, I remember, oh, my significant digit says all zeros are treated to be non-significant. All non-zero digits are only significant. And I come forward and give you a rupee coin. You will say, bye, this is what I learned from you. So am I to say that all zeros become insignificant? We Indians, after discovering zero, do we try to say zeros are insignificant? Absolutely no. Then when will a zero also becomes significant? When am I treating zeros to be considered significant? It is according to the second rule, which says all zeros between two non-zero digits. The number of zeros between two non-zero digits are always significant. My problem is solved. Some significance is given to my zero. So when is zero becoming significant? When it is between two non-zero digits. For example, I consider the number 1, 0, 1. How many digits I have here? 3. Now the issue is, can I treat this 0 to be significant? Yes, students, the 0 has to be significant because it is between two non-zero digits. Here 1 is a non-zero digit. Again 1 is a non-zero digit. So 0 between two non-zero digits is significant. Therefore, I have 3 significant digits here. Next, 1, 2, 0, 0, 1. I have 2 zeros between two non-zero digits. Please to observe, the 0 and 0 is in between 2 and 1. Very clearly, 2 and 1 are non-zero digits. Therefore, these 2 zeros also become significant. So totally, how many significant digits? 1, 2, 3, 4, 5. So very clearly from the second rule, I am following that any number of zeros which are present between two non-zero digits, ಎರಡು non-zero digitಗಳ ಮಧ್ಯೆ ಎಷ್ಟು ಝೀರೋಗಳು ಬಂದ್ರೂ ಆ ಝೀರೋಗಳನ್ನ ಸಿಗ್ನಿಫಿಕೆಂಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಫೈನ್. Proceeding further, this is a very, very interesting rule. What about numbers which are less than 1? How do I consider the significant digits in a number which is less than 1? Here is a solution for that. If the given number is less than 1, if I consider a number which is less than 1, the zeros on the right of the decimal point, the zeros on the right of the decimal point and to the left of non-zero digit are not significant. Slightly absurd, but very clearly I'll explain it to you all. Don't worry. It says the third rule emphasizes that if at all you are considering a number which is less than 1, then what should happen? Any number of zeros on the right of the decimal point number of zeros towards the right of the decimal point and to the left of the first non-zero digit are always insignificant. See, meaning to say, suppose 0.00147. I have considered a number 0.00147. Is this number less than 1, friends? Yes, sir. Certainly, the given number is less than 1. Now, what you have to do is consider the zeros towards the right of the decimal point. This is the decimal point. Consider the number of zeros towards the right of the decimal point. Until where? Until the left of the first non-zero digit, or in simple terms, consider the number of zeros until the left of the first non-zero digit. The first non-zero digit here is 1. Consider the number of zeros towards its left, and these number of zeros is always insignificant. Therefore, in this number, we have 1, 2, 3. 3 significant digits. Again, I repeat here, if the given number is less than 1, as you can see here, then count the number of zeros until where? Until the left of the first non-zero digit. And these number of zeros are always treated to be insignificant. Now, for example, 0.00201. Again, very clearly, the given number certainly is less than 1. So I will consider the number of zeros to the left of 2, first non-zero digit, and I say they are insignificant. But what about this 0? This 0 is present between 2 and 1. This 0 is present between 2 non-zero digits. Therefore, it has to be significant as told by my rule 2. So again here, there are 3 significant digits. So please to understand, students, if you are considering a number which is less than 1, a number which is less than 1, in simple thoughts, don't worry, count the number of zeros until the left of the first non-zero digit. A first non-zero digit ಏನಿರುತ್ತೆ ಅದ್ರ ಲೆಫ್ಟ್ ತನಕ ನಂಬರ್ ಆಫ್ zeros ಕೌಂಟ್ ಮಾಡಿ, and those number of zeros are always insignificant. So this is how we write the number of significant digits in a number less than 1. Going to the next rule. The trailing zeros in a number without a decimal point are not significant. See, very beautiful rule. Nan yen helide? I will understand the rules, and finally, after understanding the rules, I will try to get the definition of significant digit. Probably this rule defines what is a significant digit. It says the trailing zeros. Trailing andre following anta artha. The trailing zeros in a number. Following what? I'll come to that. Without a decimal point are insignificant. For example, consider 100. The number 100. Have I put a decimal point here? No, sir. So it is a number without a decimal point. So there are 2 zeros which follow a non-zero digit, that is 1. There are 2 zeros following a non-zero digit, that is 1. 2 trailing zeros without a decimal point, which are considered to be insignificant. Why? There is no decimal point, sir. So what if there is no decimal point? The number of zeros which follow a non-zero digit, they are always insignificant. So dear friends, how many significant digits here? 1. Why have I considered these 2 zeros to be insignificant? Because they are 2 zeros without a decimal point. Now, 1 0 1 0 0. Again, do I have a decimal point? No, sir. What about these 2 zeros? They are insignificant, sir. Why? This is a number without a decimal point. So any number of zeros following a non-zero digit is insignificant. What about this 0, sir? That is in between 2 non-zero digits. My rule 2 clearly told it has to be significant. So these 2 zeros insignificant. So 3 significant digits. So very clearly, rule 4 says that any zeros in a number without a decimal point, zeros following a non-zero digit without a decimal point are not significant. Now, rule 5. The contra of rule 4, the other way of expressing rule 4, it says the trailing zeros in any number with a decimal point become significant. See, so beautiful. The earlier rule says if there is no decimal point, the zeros following become insignificant. But here, the trailing zeros in any number with a decimal point are always significant. For example, consider the number 100.0. Now, this is a number with decimal point 100.0. So very clearly I have shown a decimal point. How many zeros follow 1 here? 3 zeros, sir. Are they significant now? Yes. Why? Because there is a decimal point. So any number of zeros with a decimal following a non-zero digit are always significant. And therefore I write here there are 4 significant digits. Now 20110.00. Is this a number with decimal point? Yes. There are 3 zeros following 1, which is a significant digit. Will these 3 become significant? Yes. Why? Because they have a decimal point. So, how many significant digits here? 1, 2, 3, 4, 5, 6, 7. 7 significant digits. So, very clearly, students, if you observe, Rule 4 told you, if the given number is without a decimal point, then any number of trailing zeros become insignificant. On the contrary, Rule 5 says, in a given number with a decimal point, any number of trailing zeros become significant. Now, the 6th one, very interesting. If the unit of a quantity is changed from one system to another, if I am changing the unit of a quantity from one system to another, the number of significant digits will always remain the same. The rule says, if the unit of a physical quantity is changed from one system of measurement to another, then the number of significant digits remains the same. See, meaning to say, suppose I measure the length of an object as 2.145 centimeter. Follow, my dear students. I have measured length in centimeters. CGS system alli length measure madidini 2.145 centimeter. How many significant digits are present here? I have 4 significant digits. 2, 1, 4 and 5. I have 4 significant digits. Now, I need to express the same measurement in meters. I want to change the system of measurement from centimeters to meters. All of you have learnt this. So what is that I have to do? 2.145 divided by 100, which is 10 power 2, centimeters to meters, which is 2.145 into 10 power plus 2 goes to the numerator. It becomes minus 2, or 0.02145 meters. See, very simple. 2.145 centimeter being converted to meter. 2.145 divided by 100 ಆಗಬೇಕು centimeter. 100 is 10 square. So 0.02145 meter. Now observe this result. Again, you have 4 significant digits. So either I have measured in CGS system or I have measured in MKS system. There are 4 significant digits, which means irrespective of the system in which I have measured, the number of significant digits do remain the same. So the rule clearly says, if the unit of a quantity is changed from one system to another, if I am changing the unit of measurement from one system to another, the number of significant digits still remain the same. Now, the last rule, and probably this is the one which will actually make me understand what is a significant digit. It says the power of 10 is always irrelevant to identify significant digits in a given number. I repeat, the power of 10 is always irrelevant, not appreciable. I don't use powers of 10 to identify significant digits in a given number. See, which means to say, suppose speed of light in vacuum 2.9979 into 10 power 8 meter per second. Speed of light in vacuum. Michelson-Morley experiment gives the accurate value as 2.9979 into 10 power 8. The rule says this 10 power 8 is irrelevant to write the number of significant digits. Don't consider the powers of 10 to write the significant digits, and therefore there are only 5 significant digits in the given number. But I have an ambiguity, students. I am not considering 10 power 8, which is such a large number. I am just eliminating 10 power 8 and I say there are only 5 significant digits, which is an absolute nonsense. 2 2.9979 into 10 power 8. Where did 10 power 8 go? Please to understand here, in the entire topic of significant digits, I never taught you all how to write the weightage of a number. I never made you all understand what is its prominence in the number system. 100 with or without a decimal is 100. Then what am I trying to understand here? What is a significant digit? My dear students, if I write 2.9979 followed by 8 zeros, it means I am certain about 2.9979. When it comes to the speed of light, I am very certain, I trust the numbers 2.9979. If at all my uncertainty starts, it is with the number of zeros. Actually, how many number of zeros? Am I reliable on those number of zeros? Am I perfect or precise in that? So, my question mark on calculation begins with 10 power 8. So, I am trusting and relying on 2.9979. Therefore, I call it as significant digits. Mass of the electron 9 into 10 power minus 31 kgs. I need to eliminate 10 power minus 31 and say there is only one significant digit. Why? I believe the mass of the electron is around this magnitude. If there is any error, it has to be 0.00031 zeros into 9. That is why we say we are eliminating or not giving any prominence to the number of zeros. So, anywhere to the power of 10, any power raised to the base 10 is insignificant to calculate significant digits. So, dear students, these are the set of rules which will help me to identify significant digits. Now, how do I use these significant digits to express my mathematical operations? How do I keep the result of any mathematical operation in terms of a significant digit? So the first rule says, during multiplication or division. So the first rule corresponds to multiplication or division. The final result should retain after you multiply or divide. Your final result should have as many significant digits. In the final result, you will retain, you will write as many significant digits as in the original number with the least number of significant digits. Yenidra artha? Tumba sulba, no exaggeration. The meaning is, we will go through this example. The certain substance of mass 4.31 kg. Mass is given to be 4.31 kg, occupies a volume of 2.1 meter cube. Mass 4.31 kg, occupies a volume of 2.1 meter cube. Calculate the density of that object. So mass is given to be 4.31. How many significant digits? 4, 3, 1. There are 3 significant digits. Volume 2.1 meter cube. 2 significant digits. Mass is known, volume is known. How will I calculate density? Mass divided by volume. 4.31 divided by 2.1. Now I suppose you get 2.0108 as the answer. This is simply to explain 4.31, 2.1. I say the density is 2.0108. How many decimals should I report the final result? Keeping in mind, I have divided 2 quantities. The rule says either you multiply or divide. The final result should have least number of significant digits. Which is the least number of significant digits? 2. Mass has 3 significant digits. Volume has 2 significant digits. So your answer should also have 2 significant digits, least number of significant digits. So density should be 2.0 kg per meter cube. So if you multiply or divide, your final result should always comprise how many significant digits? Least number of significant digits as in the given number. Now, rule 2. During addition or subtraction, now it is addition or subtraction, the final result should retain as many decimal places. Now it is not significant digits. As many decimal places with the least decimal places. Which means, see, this is value of R1, resistor 1. This is resistor 2. I have to report the answer where I am adding R1 and R2. So the answer becomes 300.10713, something like this. But here if you see, the final result should always have least decimal places. Which is the least decimal places? It is 2. Here there are 2 decimal places in R1. Here there are 3 decimal places. But the final result should have only 2 decimal places. So understand, students, if you are adding or subtracting, you report your result in terms of least decimal places. What is the least decimal in the quantities given? If you multiply or divide, it is in terms of least significant digits. Here is an assignment for you all, Rule 3, which you are very much familiar in your lower classes about shifting or approximating. So we take that as a book work and you will do the assignment. Hope you have understood the concept of significant digits. Go through it again. Come back for the next session thoroughly with significant digits. Until then, thank you all.